All right, this audio is, I don't know, the extended cut, I guess. I just did Gall Mort, it's my code name. The Gall Post-mortem, or the Urbit app ecosystem Post-mortem. I have a long walk back. I've turned around. The sun is on its descent, and I realized that the walking went a lot faster when I was talking. And yeah, I wanted to stress test what I'm doing here for a bit. No video. My video clocked out at 10%. Or, they gave me a big old warning, and so just audio here. And yeah, while I walk back, just in black here, I wanted to see if I could explain something from the video a little bit better. The thing that I want to explain, and see how far I can get with it, I want to see if I could convey the really great parts about Urbit and that namespace discipline and the specifics of how it fails in the Gall model. I don't think I did a particularly good job of that in the video, so perhaps I can talk it out in this extended, much more chill sort of option. So again, hello, I'm nordus-mocwyl. We are on a hike. It is the afternoon, and it's been it's one of the chillier days here in the fall of Central Texas. We're still walking on this pretty gnarly volcanic or coral-like rocks. This trail that I'm on, it's a total circle. If you go all the way around, it's basically a marathon. I am hoping to get to the point where I can jog around it in a day. That would be pretty awesome. We went a couple miles. Let's see, mile marker 20 to mile marker 16, so a little more than 4 actually. Oh, here I'm gonna cross some. Oh, this is actually a populated area, but I don't see anybody. One car, big old parking lot. All right, I think I'm safe to continue. Where should I start? Should I start at, here's what Urbit gets right, and here's why it's so good. Basically, the discipline in the namespace, the version control, referential transparency. Or should I talk about where Gall drops the ball there? Should I talk about the assumption Gall made about how apps operate, and where that issue comes from? I hope to if we can understand why so many of the apps disappeared, get our heads into why it blew up and then why they disappeared. And I guess for this video specifically, if we can dive into the granular reasons, I think that can help picture maybe a way to move forward. And of course, I've been around a bit and I've done some stuff with apps, but I am by no means a major player when it comes to the development stuff or the large networking concepts. I'm just kind of a simpleton that keeps on learning a little bit more and more, coming from a non-computer science background and just kind of having a lot of aha moments. It's funny here, actually, this would be good because it starts us off at the very bottom of my show notes that hopefully you were looking at instead of most of the other video, since I am going to have the discipline of not doing any graphics. I'll show the show notes and that's it. But at the very bottom, you have a quote from Rovnus Rickfer, and he says, something like this could become what we call a shrubbery. And I think that comes from reassembly. It's just it's way earlier than I ever heard the word shrubbery. It's obviously planted in the concept. It's in there, I think it's the way forward. Okay. Let's see how granular we can get. Let me recap what I did talk about as far as what's Urbit doing right. So I was trying to get into it with talking about the unique referentially transparent paths that start with your unique Urbit ID, which is really just a number. And then, what is it? Is it your name, a desk, a revision number, and then all of the files inside of it. I think that's right. And it's like I don't necessarily want to rehash that, but that those two components, the absolute unique start with your Urbit ID and the revision control, so that everything that comes after it has one and only one pointer. And if somebody makes a request at that path, like, hey, I want to see what's here on your ship in this specific location, it comes up with two options. Either here it is, well, I guess it's three options. Here it is, I can't give that to you, or it's been deleted, there's nothing there. And that's like, it's just kind of like, it's just typical sense making. Like, it's kind of why I brought up Robin Strickfer. Like, one of my favorite talks is in the 0K podcast. And I think I actually linked to it because I really love it. And there's like really specific places that I had some aha moments about, like, oh, wow, like the Urbit as a distributed network is just like, it's just the way it needs to be because of like all these uncertainties. Like, you don't know if somebody's going to get a message. So, you don't know if they're going to hear that message multiple times. So like once and only once delivery, and that guarantee is like a really big deal. Things like in this namespace, it's like something that you, like, I tried to make that connection that if you, well, I haven't made that connection, have I? Like there's a reason, like let's take breaching for a second. So everything is kind of built off of, I mean, I say that, but I'm saying that arrogantly or naively. Ignorantly, I am saying, I'm starting to see like the centrality of this referential transparency. It means that you can make assumptions about the network that you normally can't, and you have to like do things like double, triple check with people, and you can't make assumptions, and so you have to like build all these contingency plans, and you can get into like really awkward, unforeseen states if you start doing that kind of thing, and it's an issue. Let's see. Let's take one of the natural consequences. So why do you have to breach? So breaching is saying, hey, we've been talking. You know who I am. I've told you things about myself. This is your computer talking to other people, everybody on the network. Like, so yeah, I said that I had these things and these paths and that we could communicate. And we have like this log of what we've said to each other. Well, guess what? You're going to have to forget all of that because I actually need to change. Like, I don't remember, and I can't remember. Like, that's mile marker 17. I can't remember anything anymore because I'm a new person. So you're just going to, like, just take a note that you need to think of me from a completely fresh start. And it just announces to everybody. Maybe your sponsor does it. I'm not exactly sure. And you're just like, I have breached. So just pretend we haven't talked before, and we'll start over. And that's a consequence of needing everything to stay referentially transparent. And when we had the double boot problem, where you boot up on the, say your plan's on the cloud, you boot it up, and it's saying one thing to the network, and it has a big old history with the network. Everybody understands that's, it makes an assumption about what state it's in and where it is. Not necessarily where it is, but what it's thinking about what's been said. And I'm doing a terrible job of this. It's fine. We'll just keep going. And with a double boot, what you do is like you accidentally open up that Urbit like on your laptop. Like you forgot that you didn't shut it down, but you copied it over into your laptop. The version 1, the cloud version, has since said things to other people and had an event go on. And then you boot it up in a different spot on the network, and you start talking and you start trying to make a history with other people. Well, now you have two separate histories, and no one can assume anything about what you know because of this like double boot. And so now you have this like basically like a corrupted personal blockchain and there's no reconciliation. And so you just have to say, all right, start me from 0. We're going to build this all back up. And so like you have to say, I'm breaching. I declare bankruptcy. I declare breach. Yeah, you basically have to do that. How embarrassing. It comes down to this like referentially transparent namespace, the namespace discipline. And maybe if I share where Gall kind of goes wrong, we can see that a little bit better. But let me first make explicit what the Gall assumption of what an app is, which I guess is just the assumption, it's the world's assumption of what an app is. And Gall sees an app as inputs and outputs with state and the transformation of that state. In the Urbit world, so in the Gall world, you will have that Gall app written into the Clay namespace, which will be referentially transparent. And so it's the first time you write it in that space, it will have the reversion number 1, case number 1, and that's referentially transparent. The app where it's written is in that nice discipline namespace. However, the state of that app, which is remembered by Gall, and like, I don't know if it gets a revision number or not. I don't know how Gall works. I will say that. I don't know the intricacies of that, but I do know the app model. And so for Gall, it sees the state of that app as a mutable thing. So when you go from your first chess move to your second chess move and you modify the game in the state of your chess app, Gall just sees that as, oh, here's the app state. It just changed. And that's like maybe not an application, but in practice, like has become a breaking of referential transparency. So as far as I know, there's no revision number between, like, for every state morphing, straight state transformation like that. And I suppose I don't know, like I only have a vague notion of how, if it was to have that, like maybe you crack open Gall and it's like, well, no, Gall takes total, does revision. Like it knows exactly, it totally increments every single time you morph the state. And it's like, perhaps there's something useful there, but I don't totally know. But I know I can compare it to the contrast of what shrubbery does, which is a shrubbery would take that state and would just like place it into the namespace. It would make a path for it in your namespace underneath the ship, and then anytime you update it, you just morph it. So, version 1, you initialize the game with somebody. Version 2 is the first move. Version 3 is the second move. And that transformation is in there, and it's all held in state, and it's like a file in Clay. And it seems distinct. That's maybe, I don't exactly know what the juice is for having the state become referentially transparent like that. It just seems more consistent. The place where it really does fall apart is the updating of types. So if you, I just had like delayed embarrassment from the guy running past where I have a microphone attached to my backpack. And I'm just like wishing that he just thought I was talking to myself with my hands. And that whenever I pulled the microphone to my side, he couldn't see it. Oh, gosh. What saint do I pray to for that to be the case? Okay. I am not actually Catholic, but I love Catholicism. So maybe, so a better example is that type updating. So I'll do the same thing. So your structure file, which holds all your types, that exists inside of Clay. And then that gets a revision number anytime you do make a new one of those files, you'll see that revision number, and you can know, you can go back in time and see what it is and reference it, and Clay can reference it and pull it out, and it's like nothing's lost there. But ironically, when you change the types inside of the structure file, there's no automatic or internal bookkeeping for how those types change as you upgrade it. And so you have to be the one that applies the discipline to say, like, when types change. So, I guess I'll try to use a chess app example. You have to change what from version 1 to version 2, you have to change what a move is. And so that means in your SIR file, it's just going to exist as the new move type, and not the old move type. So you only have those structures. But in your state, your chess app is going to remember the old moves in the state. And that's why you build on load. You have to build the old to the new. So if you have old version 1 types, you're going to have to make some kind of branching decision about what you do with those moves. So you probably just take the old moves. If you expand it out to move, you'll want to just plug in a default, some kind of default thing to expand the old moves to be the new moves, so that whenever your app is dealing, so your app is only dealing with the version 2 move type. Otherwise, Urbit's strong static typing will crash if it receives the wrong kind of data. So on load is your chance to upgrade it from version 1 to version 2. I am still going to punt on when you go to version 3, and what do you do when you were playing with a game with somebody when you were both on version 1, but you've upgraded to version 2, and they upgraded to version 3, and you still wanted to play a game. That's really complicated, and Philip Monk explains it better. But I guess hopefully you can kind of see how there is a referential transparency solved the issue of knowing about which SIR file, it does the version control and referential transparency, the difference between SIR file 1 and SIR file 2, but it can't reach in and you have to, as a developer, do these extra things so that your apps can properly go from move type 1 to move type 2. And so, if your type definitions were inside of a transparent, referentially transparent namespace, that kind of bookkeeping could be done automatically, and that could be a way out for your apps to be able to handle you're giving me version 1 of the old moves. Okay, I know what that is. Let me go to the right structure file to grab it. And, you have version 2? Well, I know what that is too. And so Liam goes into that about different and new, making a chat app in a shrubbery and then expanding out what a chat is, but then the fact that all of your versions of chats can actually just live together inside of the namespace just fine. It's just it just handles all the things in a separate kind of way. And it's as I'm saying it, it's still kind of vague, and I'm not 100% sure. But I think the thing that I want to highlight is just what Urbit has already solved a lot of problems by having this disciplined namespace and referential transparency. And we're running into problems when it comes to the type upgrading, and we're kind of making solutions that actually look a little bit like the namespace, referential namespace, and referential transparency in the namespace discipline. Another example, and this is probably even the strongest one, which maybe I should have started that with, is essentially the paths that you make in your Gall apps on poke and on watch, you're essentially having to create your own API where it's like, okay, you want to see my chess, the state of a certain chess game or a range of chess games in a certain time, and you want to like search for it. Well, you need to come in on peak. And if you want to range, I'm going to have to create a specific peak where you get to tell me what range, give me like some dates in order to go and grab them and deliver them to you so you can read them. And so like to have that, I'm just going to go ahead and like change out the paths. And so I get to say what paths are things. And a lot of times you'll put types inside of the path. And so like essentially you have these API calls that the other person kind of just has to, they're going to have to reference something, right? Like for me, when I wanted to attempt to create interoperability with the Groups app, I had to go in and look at what their on poke says, see what the paths are, and that's not a transparent thing. It's not obvious, and I had to construct the right path to peek on, so that it sees it as a valid thing and then returns the result to me. And then even whenever it returns the result, I have to be aware of what types they're using. And this kind of gets into the distributed app issue, which is like, I have to divine what the structure of your API is so I can handle it. And every developer had to make their own API themselves, like deciding what paths to subscribe to on watch or what paths to peek into at on poke or on peek. And there is while Gall did a great job of creating the 10 arms for Gall agents to allow for distributed apps a little bit better, it doesn't go granular enough to tell people, to help somebody assume how the on poke paths would go or the on watch subscription paths work. And so you have to go find out that information in some kind of way. And you have to know how to interpret it with the proper structures when you get it. And here's one of your issues is when you change that path of on poke, say you change version 1 to version 2, you change some of your structures, and maybe that structure is embedded inside the path. So now you have to upgrade the path. Well, this introduces another issue, and so that means you kind of just have to null and void all the old peaks, or you have to do something. You have to figure out how to upgrade an old peak request into the new version, and it's just like, ugh. Who wants to be doing all that? That's so much, and it's and to rewind the clock. If you get your app perfect the first time and you never touch it, you can let it ride. You can tick up your Kelvin versions pretty much with abandon. You got to look at the GitHub release notes for any breaking changes and test it. But you will not have these problems until you change your types, until you change your paths on poke and on watch. So it's these are, and these having APIs change and stuff, it's that's an Earth problem. It's totally an Earth problem. And a Martian world would keep track of all the changes. They would be explicit, and old things would work just fine with old things that always worked. If you make a peak, so I'd assume in a shrubbery, if you were to make a peak for an old thing that you knew about, and you do it in the old way, it should just work. It should just pull out and be fine with the types because it's just like it lives together in there. And then if you wanted to look at a new thing with the new path and the new type, you should be able to pull it out without disturbing any of the other stuff. And so I think a lot of the Mars, like clay, just has this solution. It's kind of, I don't know if it's just an intuition. That's mile marker 18. I don't know if it's just intuition or how silly it is, but all I'm really doing is parroting Liam, and Liam is by far a much better, much more informed and capable person in the space. So I'm just deferring to his expertise there and just saying, you know what, I think you're right. I think we owe it to ourselves to take that shrubbery path and to see it to its... I still have at least 2 hours before the sun goes down, but I'm getting a little nervous about it. Yeah, let's see. So there you go. That's here's the beautiful kind of elegant solution that Urbit has that allows you to make assumptions over the network using referential transparency. It's the way that the Gall app model assumed how apps should be, which is the standard way, made it so that we threw away referential transparency inside of Gall. And I think the intuition is, if you don't think of apps in that same way, but instead you think of apps as just being things that exist in that namespace, then we can get past the earthly issues that we've discovered. The fault of Gall is the lack of that Martian namespace in this much more granular space inside the Gall app. Okay. I guess I'll just keep on going.